Hello everyone. Welcome to episode 3 of AI for Devs. Today we're going to be talking about Spring AI. I'm Renu and this is my co-host Michael and we are live from Singapore.
Hi everyone. So we're super excited to have you for our second episode of AI for Devs. So today we have a special guest, Christian, because we'll be talking about Spring AI. Just one thing before we start, we will actually go quite in depth into Spring AI. And you do need a little bit of background knowledge about it. So in case you guys are not familiar with Spring AI yet, we actually suggest you to go and watch this video. You can see the link on the screen right now. Awesome video about Spring AI from our friend Josh Long. So go watch this video and come back if you're not familiar with Spring AI yet. So okay, so first of all, we're going to start. So thanks a lot, Christian, for being our guest today. Christian Tzolov is the lead of Spring AI. He's one of the co-founders of Spring AI, and he's been working on it full-time for like more than 1 year, if I'm correct. And maybe, Christian, you can introduce yourself?
Yeah, thanks for having me, and really honored to be here. I always have this passion to talk about this topic, and appreciate it that you invited me for this. So, I'm part of the Spring team based here in Netherlands, and we've been working on different projects, but since last year and a half or maybe 2 years, I was co-leading along with Mark Pollock, the Spring AI project. As of recently, I also founded and I'm leading something new called Spring AI MCP, which has some additional sub-project called MCP SDK. So for Java, we can discuss this, but nowadays I'm full-time employed and working on how we as application developers, particularly Spring application developers, can harness all this new thing called Generative AI. So that's my purpose of life for the last 2 years, and I really enjoy it.
Thank you, Christian. That's wonderful. So maybe let's go back to where it all started. Can you please talk a little bit about the story behind Spring AI, how it started?
Great points. It's an interesting story. So the Spring AI is founded by my colleague and friend Mark Pollock around, I think it was during COVID times. And again, I'm telling the story that he's usually telling. So apparently he was sort of bored, had more time. I think for many people, COVID time weirdly was a period where they could actually step back and see around and try to look some alternative interesting things. So that's how he came across some podcast. I forgot the name of the podcast where they were discussing generative AI. He got interested very early and he started implementing something like the structure of the Spring AI project itself as integration project. This got the interest of some events. I think the biggest one was Microsoft event. Again, I don't remember the event, the name itself, but apparently there was a lot of traction. The community was really looking for solution in this domain, and this would prove later on to be true. So around that time, I joined the team. So I've been interested in this domain in the past as well. I was really hoping that we as Java developer can harness the benefits from the deep learning stuff. It didn't work very well back. Practically the popularity was for good reasons. But now with generative AI, it was really a success. And so I joined Mark, and we started. When I joined the project, we had actually we didn't have a vector store implementation. We had something in memory and one kind of half OpenAI integration. So that was the very first things. But even this was already creating a lot of tractions, and that's how we started. So.
And by the way, just one question on this. Is there any, how did you guys come up with the name Spring AI? Did it just come naturally? There was some discussions behind it?
It is kind of lack of imagination, I would say. So we had Spring, and mostly of our other project there, Spring something. So it was very natural that it would be Spring AI. Maybe I'm glad that we didn't specify to something like Gen AI or stuff, because Spring AI is beyond the LLM itself. It supports various other models, image, video and stuff, which is important, including the vector store semantic search we're going to discuss. This is not really generative AI, but it is kind of adjacent, different trend. So I think it's a attempt to provide integration for various portable integration. This is a Spring after all, across all these different platforms, APIs, providers, and to have kind of singular common APIs abstraction on top of this. So
thanks, Christian. So a project which was born out of boredom started with podcast, and how ironic you get to talk about it on a podcast today.
Lovely.
Yeah, just curious, how big is the team now? Like, how many people are actually working on Spring AI? What kind of external contribution do you get?
I think this is an excellent question, because for most of the time we've been, both of us, me and Mark, doing most of the coding and extending, just to convince the team and the organization that this is actually something that is valuable. I think we are already now very successful in convincing everyone. Everyone is interested in this. So now we have two other members, Sobi and Ilaya, also that are contributing. I think Ilaya is full-time to the team. So since last few months, without their help, we wouldn't have been able to make the GA release month. And also there is a lot of amount. And the reason for all this is that since I've been in Spring team, but it's not only me, even the guys that are before me, we never seen such an interest in a project. And if you get this, I don't have really other objective statistics, but if you, for example, compare the GitHub stars for the Spring AI and the rest of the Spring projects in all ecosystem, you would see that you'd never seen such a steep growth. And I think now, year and a half after, or maybe 2 years after it started, it is the third or fourth most popular Spring AI project. After Spring Framework, Spring Boot, and maybe Spring Security, I would say so, and then Spring AI. So this is a station for how popular it is. And that means that a lot of people are providing a lot of issues and contribution, more than we can actually scale and process. This is a big problem. So how to answer this community is a good problem, I guess, but at the same time it's very hard.
Thank you for that, Christian. Maybe to understand a little bit about the background also, if we take a step back, when you guys started on Spring AI, I think Java and AI were not a good match, right? I mean, nobody was doing, very little people were doing AI in Java. And basically, you had to be doing more Python or C++. And we feel now things are different because it feels like doing AI is mostly about calling APIs. I mean, not mostly, but at least in the case of Gen AI, it's mostly about calling APIs. So do you feel like the fact that now we can call AI through APIs is giving a new breath of fresh air for the Java community, and the Java community can finally go into AI?
Yeah, it has been a struggle, isn't it? So for a while, as I said, even for the 2016 or 18, I was presenting some integration for the Spring Dataflow, practically Spring integration, and TensorFlow. But it was I was really hoping that Java developers would see the benefits of doing this type of task, that they cannot do it in imperative code. But it didn't work back then, because in order to interact with the machine learning model, you had to convert your Java domain model into the machine learning model, which is usually this set of tensors, which is very unique for each model, then do this way, the opposite on the way out, which was very, and the second thing, you had to retrain the model anytime you change your use case. So there was no really one, and there was no clear, although there were a couple of attempts, never was possible to do proper retraining with pure Java itself. So there was this early project. I really hope that this would help, but it didn't work out. I mean, it never went out beyond some niche. And then Generative AI come up, and to surprise to their own creators, it was such a success story because it, in my opinion, there are two important factors. It uses human language as the interface in and out. So for in general purpose, which really simplifies the way how you can interact with it. And then you can use it for many use cases, most of use cases, without having to retrain the model. Just with providing proper instruction or changing the input instruction, you can actually change the output and practically reconfigure your system to solve different type of problems. So practically you do not need anymore, for most of the cases, the role of data scientist or data engineer to practically the application developer now can actually fulfill all these roles. I think this is a very, very significant change into the spectrum. And so on the other side, so Spring Python is very good it's been successful in creating models, trained models, but when it comes to production and enterprise, that's not really the strength what Python is and the Python development lifecycle. On the other hand, Java and Spring ecosystems been for over 30 years now, and Java and Spring for maybe 25 years. Very successful, very useful. Yeah, and you have all this huge ecosystem of developers that they really want to use these new kits and new stuff, but they do not want to retrain themselves to Python or JavaScript developers in order to use it. And I think this is the gap that we try to plug, and we I think very successful. We believe that for inference type of pipelines and processing, which is most of the cases with the case of generative AI systems, tools like based on Java and JDK in general, I think are beneficial, much more performant, and they have their advantages of pure Python kind of illusion. But it is not exclusive game. I think it is you would never have a single system in your or platform in your enterprise. So, but the likelihood that actually you have a huge Java community in your enterprise and doing something and enabling this community with proper integration with something like Spring AI or some other project into this stuff is a Java project doing similar stuff. I think is great, and I believe this is the way out.
Okay, thanks a lot, Christian. So let's actually dive a bit deeper into the technical parts. So first I wanted to ask you a question. For me, when I started with Spring AI, probably was about 1 year ago, I was really impressed about one thing, is how clean is the API. So basically I was playing with the chat client and I could see that it was very intuitive. And the way I would basically call the AI to actually get the answer to my question, or maybe generate an image, or pass an image and ask to do some OCR on the image and so on. Everything is very intuitive and using like very similar methods. Can you maybe tell us, did you guys do a lot of thinking behind it from the start? And is there a story on how you guys came up with the chat client?
Yeah, this is really glad to hear this attested for the work, because we were very nervous and it's great story, and as a background this is the Spring approach, I believe. So I've been building from the bottom up. So we are trying to provide the small abstractions at the lower level and then the next layer. So about a year ago, this time I think it was before the Spring I/O conference 2020, we already had some nice abstraction for the vector store, for chat models at this low level, and we really were looking for having high level abstractions that would become the chat client. I'm not even sure if this was the first name, but that would provide this high level abstraction to allow you to interact with this stuff. So to do this, Mark Pollock flew from New York to Amsterdam, so we joined forces here for a week or two. We did a lot of stuff, but the focus was to provide this high level abstraction API. We worked and we came with something that we were very proud with. So I think we were almost settled about this. And suddenly Josh turns out to be in town. So I think he was here for some conferences and he joined forces as well. He checked the API and made very interesting comment. Josh said, okay, no, it's not bad, but it's kind of really old-fashioned API. And to be honest, now looking through it, we practically follow the model that if someone is familiar with the old Spring security API, we kind of use this approach to, and it was, you have to go into API back and forth. It was not very intuitive to be honest now. And so we return to drawing board, and we decided to go to Arian. He's the creator for the web client, REST client API. So one of the creators, he's based here in Rotterdam.
So Ian Putzma, right, if I'm correct?
Yeah, absolutely. So, hey Arian. Thanks a lot for the help. So, three of us, with my car, we went to visit Arian in Rotterdam, spent a couple of hours discussing the whole problems, some ideas, then had a nice lunch. Come back in the evening, Joe started already coding what would become chat client to resemble the approach that already existed with the web client and REST client as abstractions behind, which was very natural. So this was the inspiration. And we just followed the whole things, and then I joined. We finished the implementation. It was about that time when I came also with the idea of the advisors. They had, which was very powerful things. Again, it's not something new. It's interceptors, or if you're familiar with AOP, it's the advisor concept where actually you can put some code on the path of your request response and practically package some behavior to do stuff with this. So it became part of the API. Important to solve many, but those together. So for practically 3 weeks we came with this design. We went to the Spring I/O, and that was it. So I'm really glad that it was the right approach to do things. And again, thanks for everyone in this process. But it is fun story. I mean, it's lovely when we get together and how much we can do. Most of my time I work remotely, but when I have the chance to work with some of my friends face to face, I think we're much more productive.
Excellent. Thank you, Christian. And by the way, one more thing I was really impressed about the first time I tried Spring AI is also about the structured outputs and the fact that actually it's really interesting idea that actually you query your LLM, but you get a result in a very expected format. And that makes me think a lot about like Hibernate, JPA, and object relational mappings in the way that, okay, it's not a database, it's actually an LLM. So, but the way I get my result is still through an entity, so it's very similar. I wonder if that was intentional in the way you guys designed it.
Okay, so but I think this is one of the this important point. LLMs, they are text models, so text in, text out. So and for most cases it is beneficial. As I mentioned earlier, the fact that you have human language as an interface with the system in and out is making it very, very useful for various use cases. And structured output, but for many cases, the moment you want like to build a system and programmatically something, the text output becomes very kind of cumbersome to handle. So you really want to have a structured output. And this idea for the structured output that we implemented as part of the chat client is a common pattern that apparently existed in the generative AI space back then. People actually were doing different way. They were even using, and they still do, functional tool called abuse in order to generate structured output. This is another technique that you can do. I usually recommend against it, but the idea with the structured output in general, and the idea is very simple. You pass a JSON schema representation of the structure that you would like to have, along with your user question input as a schema, and then back the LLM to provide the output into this particular JSON. So you're adding additional system messaging explaining that you would like to have exactly this format. And because Spring AI already provides has all these converters and infrastructure underneath, it is very easy to build an API at API level just to use plain Java types. Spring AI will take care to generate the JSON schema for these types, do the whole plumbing for the prompt underneath, and then on the way out, convert those JSON responses within the desired Java types. Here it's important to point out, so, and this is generic schema that works across most of the models pretty good most of the time. Over time, some of the providers started to provide a native structured output support, like OpenAI and I think Anthropic right now, that allow you to do this. So Spring AI supports this at the chat model level. We have a PR to support it to the chat client level. The idea there is that chat client will try to check if the underlying API provides a native structured support, use it, otherwise you would kind of fall back to what is generic implementation like this. The idea is to strengthen the provide better guarantees for the right structured output, because 1 in 10, 1 in 100 depends on the model, 1 on 1000 case attempts, practically the LLM won't produce the desired output model. So the other approach to solve this is to retry. So you have to have a validation at the output, see if this is the desired, or if it's not, try again. Most likely the second attempt would be successful. And recently I saw that Thomas Vitale had an advisor implementation for JSON that does these bits. Practically you can plug advisor that internally is doing the looping, and this looping idea is new, so we are kind of considering whether we should allow the advisors to allow to loop within themselves, and this would solve all sort of problem. Practically you can do the tool calling at the advisors level, which has many benefits, or even implement some agentic looping within the chat client. So there is a very interesting new development going on into the part.
Christian, like we are talking about the APIs, LLM APIs, we have so many of them now, OpenAI, Gemini, Anthropic, right? So what is your point of view on where exactly is it heading towards? Is it that there is one pack which is leading, let's say OpenAI, and others are just following? Or how are you seeing this going?
That's a good observation about OpenAI, to be honest. So it seems like OpenAI started, everyone followed. So we have some divergence. We have some, for example, the Anthropic Google Gemini APIs are quite different from the OpenAI API, but many of the other, for example, Mistral's own API is very close. So if you see its implementation as an API to the OpenAI, and furthermore, many of the providers, LLM providers nowadays, support OpenAI API as a second API next to their native API. So there is this kind of convergence. For example, NVIDIA or Perplexity, Grok with Q. So for many of those, you can really reuse. Even big providers like Google Gemini supports OpenAI as a kind of secondary. There is a good reason for this. There is a lot of tools that support OpenAI out there, so you can easily plug it with. On that sense, that's a kind of common theme that OpenAI creates something everyone tries to follow. But at the same time, there is a huge diversity of APIs and they have small details. Recently, we provided, for example, DeepSeek integration. Initially, we tried to reuse the OpenAI API until we noticed that actually there's some divergence and we had to create a dedicated branch of it. So while the OpenAI is leading as a concept and most parts, it would be common that every particular provider would have its own specific advantages and changes in the API that you'd have to provide and support. And this was a big story in the Spring AI project itself. It's an integration problem. So we wanted, and we're still trying to provide a common abstraction, portable. The point is that very often you have to change your prompts along with changing the configuration. So this is another kind of human programming bits, but it is a common theme. And yeah, I don't think we would ever converge only to the OpenAI, so that's my simple story, but it would be kind of a very good escape for cases where we do not support the native API, and that's what we're doing with the Spring AI as well as a second door. But we already have support for, I don't know, 10, 15, 20 different providers.
Let's talk now about a different topic. We hear more and more about functions and tools, and in particular, like at the beginning, like I had an annotation in Spring AI, which was, if I remember properly, it was add function, where actually I could have my own function. And I don't know what happened, but about like 3 to 4 months ago, it's like nobody is talking about functions anymore, but everybody is talking about tools. And maybe to give some context, maybe some people are not familiar with what we mean by function. It's basically I'm exposing one function or one method, one Java method, which I wrote myself. I just put an annotation on top of it, and the LLM can call it when appropriate. Okay, so if I ask what is the weather today, actually the LLM can call my function at the right time and get the result and provide it as part of the response from the LLM, basically. So for that, we used to talk about functions before. Now we talk about tools. I never understood why the change of name and why everybody is talking about tools now and not about functions anymore.
Initially, OpenAI API actually had function calling API. That was the terminology. Over time, they changed it to tool calling, and there is a good reason why they did this. They realized that function calling is one particular way, maybe the most popular one, but they started to build APIs like Assistant API where they were doing something like code generation. And this was another type of tool. Arguably, you can do code generation as a part of the implementation of function calling, but they decided they would like to have more distinct types of different tool callings. So that, for example, code generation would be one type, and the function calling would be special type of tool calling stuff. So nowadays, the irony is that tool calling and function calling are kind of used mostly interchangeably. But yeah, because most of the time people aim, and when they say tool calling, they mean function calling. No one actually talks about code generation, or even if they do, they mean code generation via function calling itself. But this is the story behind it. I think it's one of the most important capabilities, as I said, for the generative AI to allow you to integrate your application with generative AI. So practically it provides you with the ability to make the generative AI request real-time information and augment constantly, improve its response.
Thank you, Christian. So as we keep on talking about, things keep on changing every month, every minute, every week or so, right? So, okay, we had functions, we had tools, we also have something called MCP now, Model Context Protocol. Once again, this is the latest hype. Everybody is talking about it, using it. Maybe walk us through what is MCP?
Yeah, that's an interesting story as well from the integration space, and a very successful story apparently. Yeah, at least very popular story. So we shall see how successful it is. Hopefully it will be. So far it is. But so from the usually when I try to explain the MCP, I'm trying to walk you, and already we discussed mentioned about the ability of the generative AI to acquire additional domain data with the means of, to be provided with the domain data with the means of the vector stores and the RAG techniques, prompt stuffing. Then you can use the tool calling or function calling to provide real-time access for to the LLM about your APIs. and additional real-time information. And anytime as an application developer, when you start to build your application, you have to figure out how to do this type of plumbing integration. So you have to figure out what data you would like to put in the vector store, how to chunk it, how to provide it to the LLM, how to stuff it. And then you have to think as application developer, AI developer, how your application is going to interact with the environment. So this is the second bit. And in the space of agentic systems, which are very popular nowadays, the common metaphor is that the LLM represents the brain of the agent. It is these things that knows how to plan the path towards solving the problem, user-defined problem. And then in order to solve this problem, most likely the LLM have to interact with the environment. In order to interact with the environment, you need to use tools to ask some data or change some data in the environment or act upon it. And as I mentioned, as application developer, up until recently, you had to think about what tools you need to put in your application. You have to implement these methods yourself. And if you do another application, maybe you'll be able to reuse something, maybe not. But what about all this ecosystem of huge ecosystem, Python, JavaScript, Go, .NET, name it, already implemented tools that exist out there and frameworks that provide such type of tools, integrations, but you cannot access, you have to implement it itself with your application over and over again. About November, I think at the end of the last year, Anthropic came with a proposal called Model Context Protocol, which aim to unify the access to these external resources, including tools, prompts, and something they call MCP resources as well. So most of the time people using the tools concept, but again, the idea is that you can split the problem now. The MCP is a client-server protocol. So on the server side, this is the responsibilities of application providers, usually the people that provide database or some third-party systems would build a very thin wrapper around their system using their native API to communicate with this system. On the outside side, they're going to expose the unified, interoperable MCP access point. So this provides this kind of common access to this API, and this MCP protocol allows you to list what tools are available, code tools, get notified if tools change or prompt change or list change. On the client side, now as an application developer, when you start building your AI application, you can start building, focus on the prompts, but you do not have to worry about the tools or the capabilities that you can have to assign and build in your AI application, because you can do this very easily just by adding a MCP client connected to particular server, that MCP server you want to get the tools access to it, and you can have multiple at the same time. And what is even more interesting, you can do this at start time, so practically you connect to the server, but because of the dynamic nature of this protocol, the server over time can add additional tools and let the client notify practically at real time without changing your AI application anymore, without restarting it. It suddenly can be much more capable. For example, it's very trivial for the Spring AI now to connect and provide, for example, to connect to the Brave, which is the internet search API, which is just a few lines of code, of configurations, and for example, your local file system, and suddenly you can ask questions that would go browse internet and write the result into your file system in markdown format, with just few lines of code without a few lines of configuration, no code, nothing. So it's, or for example, if you want to integrate with your GitHub repository, again, there is an MCP server, and actually there is an explosion of MCP server supports out there. And people now working on proper discoverability protocol. That's another interesting fix. This is work that is happening inside the MCP group as well as outside. So on the Java side, very first week when this came out, it was obvious that this integration problem, it really helps Spring AI. So we jumped in and implemented a prototype, I think in 2 weeks or a week or something. Then we continued. This was around the Christmas. Maybe this was the lucky time I spent most of my Christmas holidays coding these bits. Not that much for my family, but lucky for us, we actually managed to, and we came with a solution. We got recognized, because we were very early in the Spring ecosystem, into the MCP ecosystem implementation. We got contacted by the Anthropic and David. Thanks David a lot. And over time, we decided some parts of what we did makes sense to be donated as a general MCP Java SDK implementation with MCP, and we still maintain it, and there is a lot of ongoing work and yet another stream of a lot of contributions and even sometimes controversy about this. But when we did this, and I think we were the fourth, there was officially MCP started with by default with Python and JavaScript. implementation. I think Kotlin very quickly came with SDK, and we at Java we provided the Java SDK practically a few weeks later, but let's say a month after the original. So we were very quick to provide a Java implementation, and this comes back to the question about the Java versus Python and ecosystems. I got a couple of comments from the community saying that they're really excited for the first time to see that Java is in pair with the Python and ecosystem rather than just trying to catch up. And I'm really pleased with the comments like this. So there is a lot of problem to solve in the security, scalability. It turns out, for example, that suddenly now when you connect to multiple MCP server, you have like 100 plus tools available and registered in your. So the problem becomes how to filter those, how to deduplicate those, all these bits that I've never thought before when we actually, as AI developers, used to build the tools by ourselves. We were in control. So service providers built the MCP server using the best knowledge he knows about the native API, and the application provider, application developer, we as application developer can just benefit from this using the unified protocol and to access this service over the MCP protocol itself.
Now to talk about another topic which is also quite hype right now. If we talk about agentic AI, so it's interesting, 4 months ago everybody was talking about Gen AI and so on, and now it seems like we're all talking about agentic AI. And so we would like to understand a little bit what Spring AI does and does not in terms of agentic AI. Like, can we consider that Spring AI is an agentic framework, or would it help you to write agents? Like, what is it exactly? Can you explain?
Okay, let's return first to the very basic definition. What common understanding about the agent is, at least to my understanding. So this is the definition sounds something like this: that the agentic system, and I'll talk about system. I'll explain why. Agentic system is such system that uses the generative AI in order to interact with this environment to solve user-defined problems. Okay, so it brings together all this under the hood. It uses the LLM as a brain, as I mentioned earlier. So this is the part that knows how to break the problem or split the problem into steps in order to solve the user-defined problem, to find a solution for user-defined problem. In the way to solve this problem, most likely you would interact with the environment. You have to interact with the environment. So the body of the agent is kind of represented by the tools. Now we saw that the tools itself can be unified with MCP. Practically this can be something that, but yeah, so you have the agent, which has the brain, the body. Additionally, as we mentioned, the LLMs itself is stateless. You have to figure out how to maintain memory. And there is a different schools and way how do you do this, prescriptive versus autonomous. And again, this is less agentic versus more agentic approach, but memory is essential part of the agentic system. And agentic loop, this is the last concept. What agentic loop means, for the case of single agent, that means that you would have a situation, a flow where the agent produces an output, and then the same or different agent, let's say the same agent, evaluates the results and decides if the result is solving the user defined problem. If not, make some amendment and try another time, usually until some number of attempts are exhausted and stuff like this. Usually it's not one step, so this loop represents these iterative attempts in order to get there. That means that instead of trying to have the perfect prompt, single shot on the LLM and find the solution, you're going to iteratively try to improve your prompt and get some additional information, reframe, in order to get to the solution part. And this is for the case of the single agent itself, which do these iterative bits. There is no single true agentic architecture or agentic implementation, so it is a spectrum of solutions. The spectrum is determined mostly on the basis how prescriptive or autonomous the solution is. You can have a solutions where problems where you as a human know upfront what are the steps you need in order to solve the problem. So most likely you want to design these steps. Each of these steps itself would be LLM, input, output, maybe interaction with the tools or MCP. Then the output of this step, this LLM, would be the input for the next one. Then another pattern is called very common pattern is called orchestration, which we have an orchestrator agent or LLM that is instructed to generate, practically to evaluate the input and provide, generate practically system prompts or prompts for all sequential steps that you would like your system to perform. Usually they could be sequential, parallel. You're delegating now to the agent to decide how to design, to build a workflow and to make it. At the end, if both cases, you would have to have a loop that goes either a big loop across from the end to the beginning. This is the agentic loop to evaluate the solutions. That where you have the producer of the response or also evaluation pattern is used for this. You have usually two models. It could be even the same model, the same LLM, but instructed to do two different roles. The first role is to solve the problem, and the second LLM is instructed to evaluate the output of the first one, provide some feedbacks, and return to the first. So this kind of evaluation, it's used for various use cases. It's used for example, improving the output, any system, and yeah. But the point is that there is no single true solution, single true agentic system. It is a spectrum of approaches, and usually you can mix and match those systems. So the rule of thumb is that if you can solve your problem with a simple solution, prescriptive solution, and I agree with this, go with it. Even better, if you can have a solution where a single shot solves your problem, this is the best solution you can have for your engineering solution you can have. So now back to the Spring AI questions. Spring AI as of the moment really helps you to build agentic system. All this different spectrum of agentic system. I published a blog that shows how to implement all these patterns from Anthropic for all this range of things, and so it's pretty easy to do this with the chat client and Spring AI in general. There is already in the Spring AI community a version of this that tries to implement these 5 patterns but using the MCP underneath. They can do, for example, the current implementation support the orchestration pattern. Another approach, things that I'm working on right now is very interesting, and this is very popular approach. It's called MemGPT. This is techniques where you delegate to the LLM itself its ability to manage to orchestrate its memory that is passed in, and it has the concept of archival memory, recall memory. It can summarize, and actually all this is done with the help of tools. You provide the LLM with tools that allows you to write, and there's a concept of core memory. For example, read, search this, retrieve information, put information into vector store, which is called archival memory, retrieve it from there. So I'll publish this work, open this work very soon, but I'm really happy with the way how Spring AI allowed me to build this level abstraction. So from the agentic standpoint, I believe we have everything on the Spring AI side to build various agentic framework.
Thank you, Christian. Wow, we discussed a lot. If you can summarize that, looking forward, what exactly can we really be excited about in Spring AI, let's say in a year or two from now on?
Yeah, so obviously the agentic part is very important. So it's important to realize that this part of the problem with the Spring AI compared to any of the other project I've worked with, the ecosystem is constantly changing. So we are trying to provide these common abstractions and stuff, but for example, over time, Vertex, Gemini, changed 3 times drastically their APIs. So they already decommissioned the Palm 2, that was our initial API integration. Now I think the next layer, so they introduced the unified API, which we still have to implement, and the current API most likely is going to be deprecated as well. So it seems like there is this constant evolution of APIs in which we have to try to catch up and to support a new coming, which are for better. I'm not seeing they really converge into a single API, it's only OpenAI. So I think we would always be forced to try to keep up with all these new developments. So I think this would be a constant effort and expand the breadth as necessary. Figure out how the agentic scope, this is the most interesting part for me, figure out how this agentic space would play out, how people are going to use it. Again, the communication between agents is still an open topic. Everyone is trying to handle this in the proper way. There is different approaches, so this would be another place where something like Spring as an integration maybe would be able to provide a unified abstraction if there is a different approaches to allow you to provide this agent-to-agent communication.
You rightly said, Christian, we do not know what's going to happen in 2 months, so it's very hard for us to say what's coming in a year or so. But this brings us to the end of our podcast today. I learned a lot. I used to be a Java developer a couple of years back, and of course we moved along the way. So this has been a very insightful session for me. We learned about how we all started. We learned about that we have a good problem of so many contributions. I think that's a great problem to have. The fast-paced delivery to the community, like you mentioned, you contributed to the Java software development kit for MCP protocol to Anthropic. I think really amazing learning and many, many more interesting things to come. So thank you so much for taking your time with us today. I hope along with me and Michael, everybody got to know the exciting story behind Spring AI.
Thank you very much. Yeah, it's my honor and appreciate for the time spent. As you can see, I'm really passionate about this topic, so always love discussing it with people that are interesting, like-minded people, so appreciate it. I really want to wish you a lot of success. I'm excited that the effort you're putting and stuff. So as I said, I start learning and listening to podcasts with the dawn of the Gen AI, and I really love the approach. I think I learn a lot about those news outcasts. So appreciate
Excellent.
Thank you so much. Thank you.
Thank you so
Cheers.
much, Christian. Cheers.